Today's subject will be 230.90A along with its exceptions. We get questions occasionally how do you apply 230.90A in relationship with 230.42A1 where you size the conductors. So before we really get into this in any detail, let's just turn over to page 95 in the first edition of your code book. And let's review 230.90A, which is on the right-hand side of the page. And it reads, it's really 230.90A as in Apple, ungrounded conductors is our title head. Such protection shall be provided by an overcurrent device in series with each ungrounded conductor and have a rating or setting that would protect the conductor. And a set of fuses could be used to provide the same type of protection. And basically, that's what this section is talking about. And then it's kind of reads in the last sentence of the paragraph, single pole circuit breakers grouped in accordance with 230.71B as in boy on page 93 approximately in your code book. 230.71 allows 2 to 6 disconnecting means or overcurrent protection devices. And then 230.72 says that they have to be grouped. Now you can kind of look that up and read it if you feel like it's necessary. But 230.70, 230.71, and 230.72 to me kind of ties directly to this 230.90. Now the next section I'd like to read with you is 230.80. It's on page 94, right-hand side of the page. And it talks about the combined ratings of your disconnects, 2 to 6, where the service disconnecting means consist of more than one switch or circuit breaker, as permitted in 230.71, the combined ratings of the disconnect switches have to be equivalent to one switch, so to speak, or one overcurrent device, and protect the ampacity of the conductors. Now that's kind of what we're reviewing there. And then the next, I would say is important, is 230.79. And it reads the rating of the service disconnecting switch. And it basically says the service disconnecting main shall have a rating not less than the calculated load, and of course that calculated load is in accordance with 230.42A1, and also after you perform the calculations, your disconnecting means and everything have to meet this 230.79. We have to make sure we comply with that. And then the final one I'd like to go over with you would be 230.91, and that's on page 95 on the right-hand side of your code book down toward the bottom. And it basically reads, the service overcurrent protection device should be an integral part of the service disconnecting means or shall be located immediately adjacent thereto. Where fuses are used as the service overcurrent protection device, the disconnecting main should be located ahead of the supply side of the fuses. Now you know what supply side is. There's no overcurrent device ahead of your conductors between, say, a transformer and the overcurrent device in the service equipment or disconnecting means wherever that is located in accordance with service point and Article 100. Now, with that information that we've read, this is basically what 230.90A is talking about when you review this illustration, 230.90A. And if you notice in the information given in the illustration and in the figure, service entrance conductors, 1/0 THW in copper, good for 150 amps. Now we've calculated the size of the service conductors in accordance with this 250.142A1 here, and determine exactly. And really, when you talk about 250.142A1, that's grounding on the supply side. We calculate the load by 230.42A1. So let me clarify that. Now notice we also have 150 amp fuses in this disconnect. And the 150 amp fuses protects the conductor supplying the service equipment here. This disconnect means location. And then notice, for it to be a disconnect that's acceptable by the code, we'd go to 408.8A, and it could not be located more than 6 foot 7 inches to the center of that handle from the finished grade where the disconnect is installed. And then for the figure loop, we can find these different switches and their heights in figure 10-36 of our Stallcup's electrical design book. Now, sizing the overcurrent protection device, then, it's a 1/0 THW copper conductor. So step 1, 230.90A, instructs us that a 1/0 requires a 150 amp overcurrent protection device in accordance with 240.6A. And then, of course, the 1/0 conductor gets its 150 amp rating from table 310.16 in the NEC. And then, of course, you see we have the important NEC loop if you want to do a more in-depth case study. In 230.42A1, we calculate the load to determine the service entrance conductors based upon continuous load, non-continuous load, and loads with demand factors. So we apply 230.42A1 and A2 to accomplish this task. 230.90A, we have to select the overcurrent device to protect those conductors. And then, of course, in 240.4, we have information that's closely related to the 3 bullets that you see in the NEC loop above it. And basically, the ungrounded conductor or conductors have to be protected at their ampacity now in accordance with 230.90A. Now we're going to apply some of the exceptions to the rule in our next videos coming up. Now let's look at this figure 18-12, and it's from Stallcup's Electrical Design Book, Volume 2. And we're looking at the exception 1 to 230.90A, which reads, for motor starting currents ratings that comply with 430.52, 430.62, and 430.63. Now we know 430.52 would actually apply, to sizing the overcurrent device for the largest motor. And then 430.62 and 430.63 deals where you have more than one motor on a feeder, plus other loads that you see in this illustration. And basically what that exception 1 is allowing you to do, after the feeder calculation has been made, or the service calculation has been made, as you see in the illustration, 230.42A1 calculates the service conductors, and 215.2A1 would size the conductors for the feeder. So basically, based upon a large number of motors, the overcurrent protection device ahead of the feeder or even ahead of the service conductors will be enlarged, or can be enlarged by that exception 1, based upon the starting currents of those motors would trip it open if you didn't oversize it. So basically what this exception 1 to 430.90A is really telling us that we can do is size the overcurrent protection device that you see in the service equipment larger than the ampacity of the conductors. be sized up sometimes 250% higher, and the conductors are not brought along with that calculation. So that's what the exception 1 allows, is just increase the overcurrent protection device in size above the ampacity of the conductors to allow large motors with large inrush currents to start and accelerate the load without tripping your main. Or we'd have to use some kind of reduced starting on some of these large motors or feeders to prevent the inrush current reaching the breaker. So basically that's what this figure 18-12 is illustrating in the exception number 1 to 230.90A. Now let's take a look at the exception number 2 to 230.90A, and this is figure 6-44 from Stallcup's Electrical Design Book, Volume 2. Now on page 95 on the right-hand side of the page, we'll continue reading. And notice the exception 2, it states that fuses and circuit breakers with a rating that complies with 240.4B, which is, you can round it down if it's 800 amps or less in rating. Over 800 amps, you'd round it up by 240.4C, you see there. And then 240.6 refers you to table 240.6A to select your overcurrent protection device, either rounding down or rounding up. Now what this exception 2 allows you to do, as you see in the illustration 6-44, is that the overcurrent protection device shall be permitted to be used if not a standard size. Now what that means, if you have an odd size, like if you had 800 and you had 850, but it wasn't listed in table 240.6A, you could still use it. Now, sizing the overcurrent protection device based upon the ampacity of the conductors, step 1 in the boxed in information. We're applying the exception 2 to 230.90A. A 4-aught conductor will permit by 240.4B to round up above it to 250 amps if need be. And in one case, you just want the full 230 amps from the 75-degree column in table 310.16. Or the 250 overcurrent device could be rounded up because you had a bunch of fractional horsepower motors, and doing the calculation of sizing the largest overcurrent device for any one motor and adding the other motors to it and rounding down like 430.62 requires your overcurrent device, you couldn't round it up to 250. So this exception number 2 allows you to round it up because you want to get the benefit of the 230 amps per conductor, or because you're rounding it up because fractional horsepower motors and small motors would not allow you to round up per 430.62 of the code. So that's what this exception 2 to 230.90A in the Stallcup's Electrical Design Book, figure 6-44. Now let's look at this figure 6-45 in Stallcup's Electrical Design Book, Volume 2. And we're going to look at the exception 3. Now before we apply it, again, let's read what it says on page 95 of your first printing of your code book. And the exception number 3 talks about 2 to 6 circuit breakers or set of fuses shall be permitted as the overcurrent protection device to provide protection for the service conductors from short circuits and ground faults, and allow motors to start and run in some cases, and in other cases just it's dealing with inrush currents that will cause nuisance tripping of the overcurrent protection device. But notice we can have in the illustration 2 to 6 disconnects, or we can have just one overcurrent protection device. Now what this is saying, when you look at the illustration, the size of the conductors are 4-aught THW copper conductors parallel 3 times, giving us 690 amp. Now 240.4b, as in boy, says we can round up the overcurrent device above that ampacity and get the full ampacity of 690, so the overcurrent device in the panel board to the right would be 700 amps as permitted in 230.90 exception number 2, and also 240.4b as in boy in the code. Or this is the one that gets a lot of people, because when you review the 2 to 6 disconnects to the left, you must review 230.80, 230.79, and 230.91 in the NEC, along with this exception 3 to 230.98. Now notice in the illustration, we have a 225 amp disconnect, a 250, 200, 200, 175, and 200. Adding all of those disconnects up, we come to 1250 amps. But yet the calculated load in the service raceway that's supplying that auxiliary gutter, notice that we have a 250 kc mill, which would equal 255 from the 75-degree column. 3 times that is 765. So what this exception 3 is saying, that as long as the 765 will supply all the loads that you see those disconnects supplying, then if the loads kind of correspond with table 240.4G, and our calculated load complies with table 220.3, then this is permissible, because these overcurrent devices are sized, or fuses are sized larger to allow equipment with high inrush current to operate, accelerate the load, drive the load without nuisance tripping. Overload protection would be provided as a second stage of protection, like in an MCC or in a controller or combination controller. However, each individual piece of equipment is set up that has this inrush characteristic to it. And that's exactly now what this section 230.90A exception 3 and I figure 6-45 is illustrating. Then notice we do have the 2 to 6 disconnect rule here in accordance with 230.71, which allows 2 to 6, and then they're grouped by 230.72 as you see in the illustration. So we do comply with the exception 3 to 230.90A and our figure 6-45. Now let's take a look at this exception number 4 to 230.90A, and before we discuss it, let's just read what the code has to say about it. So going over to exception number 4 on page 95 of your first printing of your code book, exception number 4 reads, overload protection for fire pump supply conductors shall comply with 695.4B2A. That's around page 601 of the code. So, you know, your fire pump controller usually has your overload type protection for the fire pump. But the overcurrent protection device, as you see in our illustration to the right, titled Overcurrent Protection and Panel Board, well, that's the overcurrent protection device has been designed by 695.5B, 695.4B1, and then, of course, exception 4 to 230.90A. These supply conductors, then they have been sized to comply with 695.6A and B. And then, of course, the routing of the feeder for protection, 695.6A2. The fire pump controller can be discussed in 695.12. The pump wiring now from the load side of the fire pump controller to the fire pump itself, 695.6D is in dog. And of course, we have the motor listed as a 60 horsepower, 460 volt, three phase. And for the sake of the illustration, we had design B type motor for the fire pump. Now, the exception 4 allows the overcurrent protection device in your panel board or service equipment to be sized to allow the fire pump to operate to failure. However, it will clear, due to a short circuit or a ground fault if that should occur. Now, one thing that's kind of interesting here, NFPA 20 in chapter 9 and section 9 talks about reliable power. And they consider a utility as reliable power if the power does not go down within 4 hours collectively in a year. And they recommend this as reliable power. And if that can't be done, and the authority having jurisdiction does not allow a tap ahead of the main in accordance with 230.82 on the supply side, then a generator is usually installed as an alternate power source in case you should lose the utility. Then it will naturally come on and operate in case the fire pump is needed. Now, that's in accordance with 705.12 of the NEC. So this figure is illustrating how a fire pump should be protected. Usually at the fire pump controller, that's where it's protected from any type of an overload condition, if that be the case. But the overcurrent device back upstream is designed to allow the fire pump to operate to failure. And of course, we can go to Article 695 and obtain this information if you need to get that deep into the design. All we're saying here is that the exception 4 to 230.90A allows the overcurrent device at the service equipment, if that be the case, to be sized in such a manner to allow the fire pump to operate until failure. And that's exactly what our figure 6-46 illustrates in Stallcup's Electrical Design Book, Volume 1. Now, the figure 18-76 that we're reviewing comes from Stallcup's Electrical Design Book, Volume 2. So this kind of explains the application of exception 4 to 230.90A. Now we're going to review the exception 5 to 230.90A in our figure 6-47 from Stallcup's Electrical Design Book, Volume 1, and see what's allowed here. And this deals with a dwelling unit. Now notice in our NEC loop in the illustration, we're applying exception 5 to 230.90A. In accordance with 250.24C1, dealing, with the grounded conductor coming in and so forth, the neutral, and 230.42A, B, and C, and I would add in 220.61 for the neutral, because we will have a neutral. But the rule is in 310.12 and table 310.12, around page 156, I think, in the first printing of the NEC. Now, the loads, we have phases 192, ungrounded phase conductors. Neutral, 85 amps. The dwelling unit, we're going to size the service conductors in accordance with 310.12. Now, in past editions of the code, look at your quick calc down to the right-hand side of the illustration. They would apply 310.12 A and B, and it was an 83% rule. In other words, they take the 192 for the phases ungrounded, take 83% of it, and the service would have to be 159, so that'd be a 2-alt, wouldn't it? Now, they've gone back to the table in previous editions of the code. And table 310.12 now states that conductors, in the table 0 through 2,000 volts. The phases A and B, we have two 2-alt THW copper conductors based on the 159 amp and the neutral number 4 THWN based upon 85 amp. And then, of course, we would take the 2-alt conductors that we would have in the service equipment raceway, as you see in the illustration. And, of course, we'd apply table 250.102C1, and your grounded neutral conductor that you see in the illustration there has to be equivalent to that table 250.102C1 based upon the 2-alt, and I believe that's only the number 4 complies, so the neutral would satisfy 220.61 along with the table 250.102C1, and that's what our figure 6-47 is showing, that you can apply the optional calculation and reduce the size of the service entrance conductors that supply power to the panel board with its overcurrent protection devices, supplying powers to power to a feeder or the branch circuits inside the dwelling unit, and that's what our figure is illustrating.